And applied mathematics, we have major 3 topics. I mean 3 parts. There are 3 branches of applied mathematics, which we have main branches which I have to look at in details. The first one is called statistics. And the probability. That's the first one. It's called statistics and probability. This is the first part. Part 1. And then the second part 2, which we are calling the second one, is called mechanics. The second one is called mechanics. This is the second part. And then the third part, we are calling it part 3 of mathematics 2 is called numerical methods. Numerical methods. We have various topics under statistics and probability. We have various topics under mechanics. We have under applied mathematics. We have major 3 topics. I mean 3 parts. There are 3 branches of applied mathematics, which we have main branches which I have to look at in details. The first one is called statistics. And the probability. That's the first one. It's called statistics and probability. This is the first part. Part 1. And then the second part 2, which we are calling the second one, is called mechanics. The second one is called mechanics. This is the second part. And then the third part, we are calling it part 3 of mathematics 2 is called numerical methods. Numerical methods. We have various topics under statistics and probability. We have various topics under mechanics. We have various topics under numerical method. But we shall be tackling one part at a go. So, for our case, since we are just new to Senior 5, we are going to start with the first part, which is statistics and probability. So, we are going to start with the first part, which is statistics and probability. The first part, which is called statistics and probability. So that part is under statistics and probability. We are going to look at topics covered under statistics and the probability. So, topics covered under statistics and probability. The first one we have, the first topic 1. We have what we are calling descriptive statistics. Descriptive statistics. This is the first topic which shall cover under statistics. And then, after covering descriptive statistics, the second topic we shall cover what we are calling The second topic will be index numbers. Index numbers. The third one will be scatter diagrams. Scatter diagrams. The first one will be probability theory. The first one will be probability theory, and then the fifth one is called discrete probability distribution. The fifth topic will be discrete probability distribution. That's the first part or the first topic, and then the sixth topic shall look at binomial distribution. Binomial distribution. Then the seventh one will be, after binomial distribution, which I look at what we call continuous random, which I look at what we are calling continuous random variables. Random continuous random variables. Continuous random variables. Then that's the 7 topics which I look at as continuous random variables. And then the 8th topic, the 8th topic which I look at is called normal distribution. It's called normal distribution. The 9th topic is what we are calling normal approximation to binomial. Normal approximation to binomial. Then the last topic under statistics and probability will be sampling distributions. 10th topic will be sampling. It's called sampling distribution. Called sampling distribution. This work is enough, or this topic alone is enough to take us through the first term of Senior 5 and some part of Senior 5 second term. So, as we said earlier that this is the first part, there is part 2 which is called mechanics and part 3 which is called numerical methods. But in numerical methods, and mechanics and statistics is the only topics which we are going to cover under Maths 2 or Applied Mathematics for both Senior 5 and Senior 6. And then after covering all those 3 parts and their respective topics to be covered under them, now you are set to go and sit your name and then pass. Provided you shall put what we are going to tackle in practice, keep on practicing and doing different exercises. So, as we said, we are going to start with the first topic, which is called discrete statistics. So we are going to look at what we are calling the first topic, which shall be under applied maths, mathematics. Then we are under discrete topic 1. Descriptive statistics. Then under topic we are going to look at what we are calling introduction to statistics. Introduction to So we are going to look at what we are calling introduction to statistics. So introduction to statistics, which are the first term to be defined is statistics. We are going to start with what we are calling statistics. First and foremost, the Ugandan government always carry out census. They count your household, they count the number of people living in that household, the number of animals you have, or your assets, the amount of land you have. That data collected, or that information collected, is what we are calling data. So, as statistics is a branch of statistics is defined as statistics is a branch of mathematics which is concerned, or which deal with, which is concerned with collection organization, which is concerned collection, organization, presentation, collection, organization, presentation, and analysis of data. That is, statistics is a branch of mathematics which is deals with organization, presentation, and the analysis of data. So statistics is a branch of mathematics which is concerned with collection, organization, presentation, and analysis of data. But we say data is the information collected. Data is the information collected. If you collect information and compile them together, it's called data. So we have two types of data. That one gave us two types of data. We have two types of data. We say data is any information collected, or is the information collected. Any information collected is called data. We have two types of data. The first one we are calling it discrete data. The first one is called discrete data. This one is called discrete data. Sometimes we call it ungrouped. We have discrete data or ungrouped data. So discrete data or ungrouped data, we said if you collect information or any information collected is what we are calling data. Now, we have two types of data. One is discrete data and the other one is, the first one is discrete data, which is called ungrouped data. Here, the information which is collected by counting, and they take an integral interval, but do not lie within a given range. What am I meaning here? That if you are collecting, maybe counting the number of students in a school who are having 16 years, or who are 16 years old, you count that specific number, but with only 16 years, not saying that let me take from 15 to 17, that this one will be between those one, between 15 to 17. Here we take the specific number. If you are counting those one is 16 years, it must be 16. If you are taking 16 years, it must be 16. So this one brings us to the definition, which is called data is information. Discrete data or ungrouped data is the information collected by counting. Discrete data is the information collected by counting, and it usually takes integral values. But it does not lie within a given range. But it does not lie within a given range. So say if you are counting here, if you are collecting the information, and you are collecting information for specific number of people, let us say you want to collect information from 100 students, but you are collecting for only those one with 16 years. you take only those ones 16 years. You don't group them that let me start from 15 to 17. That in grouping them or in giving this range, I can use get the number of people with 16 years. No, you don't group them. You just take those ones with 16 years. Whoever says it's 15 and below or 17 and above, that one is out. We need only 16. That's what we are calling discrete data or ungrouped data. So the second one is called continuous data. This one sometimes we call it grouped. Grouped data. Actually, we have even finished explaining grouped data. Here now, if you want, you may say, I need to get students with 17, 18 years. So you start. As you are counting, you say, I'm counting number of students who are having years ranging from 16 to 18. Implying there, you include students with 16, you include students with 17, and then you include students with 18. That's the range which we are going to use. So that range is what we are calling, or the information collected within that range is what we are calling grouped data. So grouped data, just here from definition, which I said, is the information that takes a given, that takes values or interval values and lie within a given range. And it lies within a given range. So those are the two types of data which are built up under statistics or under descriptive statistics. We said the first one is discrete data and the second one is continuous data. We said the discrete sometimes is called ungrouped data, and then continuous is called grouped data. So that's where we shall focus most. We shall start with the first one, which is called discrete data. So we shall start with what we are calling discrete data. We shall start with what we are calling discrete data. So we shall look at number of things under discrete data. Now, what happened to that information you have collected? If you get the number of students in senior 5 is 16 years, after you have noted their number, what happened with that information collected or that data you have received. Now that's where we are going to interpreting and analyzing of data. So in this script data, we shall first look at measurements of central tendency or measures of central tendency. Measures of central tendency. Measure of central tendency. Measure of central tendency. Measure of central tendency is called this. If you are measuring the central tendency that you have values 1 to 10. Now, the measures of central tendency, we have said these are the values of the distribution that enable you to locate or to locate the central value of that information you have collected. The values, these are measurements of distribution. These are values of the distribution that enable you to locate the central value. That if you have 1 to 10, what is the central value? If you have the central or the middle value, how do you call that one? If you have the highest value, how do you call that one? If you have the number which has appeared most, how do you call that one? That's what we shall be looking at in this measure of central tendency. Now the first one which we will look at here, it is mean. The second one, median, and the last one we are going to look at what we are calling median and mode. So measure of central tendency, these are the values of the distribution that tend to locate the central values. That tend to locate the central values, and this include one, we have mean, we have model, mark, or model values. It is all the same, or we can call it as mode, which is the model mark. Let us call it mode. And we have what we are calling median. So these are the 3 values we shall be looking at, and we are going to be looking at one at a time. These are the values which we are going to use to locate the central tendency of any information collected. To locate the central tendency of any information collected. So let us start with mean. So we are at measurements of central tendencies. So we are at measure of central tendency. The first one said is mean. The first one we are saying is mean. Mean is denoted by mean. Here we are saying if you have values 1 to 4 or values 1, 2, 3, 4. Mean is the same as average. Average means after adding the all numbers you divide by 2. So I divide by the numbers of items which are there. Means it's denoted by so whenever you see this one, it shall be meaning mean. X and bar up, that one is what we are calling mean. That's the mean. If you see this one X, or if they tell you calculate the mean, you can put this one. So mean is defined by our X bar is given by summation of X out of N. Summation of X out of N. That's the value of mean. Or that's how you find the mean. Where X is the variable given, where X is the variable given and N is the number of variables, and N is the number of variables. And N is the number of variables. So that's the mean. For example, if X is equal to, let us say 1, 2, 3, 5, 6, 6, maybe 6 and 7. If X equals 1, 2, 3, 4, 5, 6, we can even stop at 5. Or at 5 will work. 1, 2, 3 and 5. So, and we say find the mean. Find the mean. If X is given by 1, 2, 3 and 5, and then the equation is saying find the mean. Find the mean. But we saw that mean is given by summation of X. This symbol here, it is meaning summation. Otherwise, we are adding from all level. This one is summation, which is meaning that adding the number of variables which are there out of the total numbers which are there. So here we shall look at Now we have said mean is given by summation. So they have said mean is given by summation of x out of n. So what is our summation of x? Summation of x equals to, these are the values. We are going to sum the values of x. Okay? We are going to sum these values of x. Now we are going to sum, that one is the same as summation of x is 1 plus 2 plus 3 and then plus 5. Our answer is giving 1 plus 2, 3, 3 plus 3, 6, 6 plus 5, that is 11. So what is our n? Our n, we say, is the number of variables. Where is our variable? Our variables is 1, 2, 3, and 5. So what is the numbers? We just count. This is 1, 2, 3, and 4. The variables are 4. So this one, our n is 4. So now our mean become summation of x, which is now 11, out of 4. What do you get? 11 divided by 4. So let me use my calculator and get that one to be sure. Divided by 4. This one we shall get 2.75. The answer is 2.75. So that's how we calculate the mean for ungrouped data if you are given variable x. If you are given variable x, we use that one. Okay? Now, that's the first step of calculating the mean. The another step if you have given assuming the mean, if you are given assume the mean, if you have assumed the mean, or if you are given assume the mean, which is the same as if you are given assumed the mean. If you are given assumed mean, sometimes you call it working mean. If you have assumed mean, or working mean is denoted by A. Assumed mean or working mean is denoted by A. So if you are given assumed mean or working mean, how do we get the mean? If you are given assumed mean or working mean, how do you get the mean? The mean is defined by our mean equals to, if you are given assumed mean, we don't get mean the same way we have been getting for the other values. What do? We get assumed mean, which is given, plus summation of d out of the number of variables out of n. So our D, but we know that our D which is the deviation is given by x, minus assumed mean. D is given by x minus assumed mean. So where x is the variable and a is the assumed mean, this one is the deviation which is defined by this one, x minus a, and then our mean is given by assumed mean plus summation of d out of n. So after getting the deviation, you add the n, the numbers of d. If you have assumed mean as 5, and then our x is, okay, let us assume that our assumed mean is 5. Example, given x equals to 1, 2, 3, and 4, and assumed mean is 2. Find the mean. So now this one we have solution. What we need to do, we go the table having the values of x, which is 1, 2, 3, and 4. Then after having value of x, what do we want? We want to get d, which is given by x minus a. Here we can have x minus a, which is d. Okay, our d equals to x minus a. So, but we know that our a equals to 2, then our x are here. So if you get x minus a, you start 1 minus 2, you get negative 1. 2 minus 2, you get 0. And then 3 minus 2, you get 1. 4 minus 2, you get 2. So you get here the summation of d, which equals 1, negative 1 plus 0, you get negative 1. And then negative 1 plus 1, you get 0. Then what will remain? You get 0 plus 2, which is 2. Then we say our mean is given by assumed mean, which is a plus summation of d out of n. Please note, summation of d, this d is the only one out of n. Assumed mean is not affected. We only have x out of n. Assumed mean d out of n, but not a. So our a was 2 plus the summation of d, which is still 2 out of n. N is 1, 2, 3, 4. So our n here is equal to 4 out of 4. Then here we follow the rule of BODMAS, which I get 2. 2 plus 2 divided by 2, we get half, which is 0.5. So this one, what do we get? We get 2.5. We get what we are calling, so our mean x bar become 2.5. That one become our mean. That's how we calculate the mean given the assumed mean. So let us look at the mean given we have the frequency. If you are given the frequency and you have the assumed mean, if you are given the frequency f, if you are given frequency f, mean is defined by mean is defined by x equals to summation of f x out of summation of f, where summation of fx is frequency times x and f is the summation of those frequency. And also if you have both frequency and the assumed mean, if you have both frequency and assumed mean, if you have both frequency and the assumed mean, we say the assumed mean is a and frequency is f. So how do we define our mean? Our mean is defined the same way, but instead here we shall change our x bar, which is assumed mean, is given by a, which is assumed mean. We say the assumed mean is not affected by division. Plus, now here we shall instead have summation of fd. There we are having summation of f only, but here we shall have summation of fd out of summation of f. So these are the almost 4 formulas we shall be using to get the assumed mean. 4 formulas we shall be using to get the assumed mean. We shall look at examples how we can get assumed mean from f, or we shall handle f or the frequency, and then now we shall get the assumed mean from fd. But here now what we know that our d is given by x minus a, which is the variable x minus the assumed mean. So those are basically what we are going, or how we are going to calculate mean and what we have looked at about mean. Those are the basic things which we are going to tackle under mean. Now what is the second value? That one was the first value, which is mean. So we are still under the measurements of central tendency. The second value is what we are calling mode. So the second value is what we are calling the mode. Mod is just the value of the distribution that appear most. As simple as that. Mod is the value of distribution of the distribution, the value of the distribution that appear most. Appear the value of distribution that appears most or that occur many times. That appears most or that occurs many times. For example, if x equals to 1, 2, 3, 4, 2, 1, 1, 2, 2, 4, 2. What is the mod? If you have the values 1, 2, 3, 4, 2, 1, 1, 2, 2, 4, 2. What is the mod? We have said the mod is the values of distribution that appears most. So, mod is the values of distribution that appears most. You come to your variables x. How many times is 1 repeating itself or appearing? It's appearing 1, 2, and 3 times. And then in 2 we have 1, 2, 3, 4, 5 times. So far the value which is appearing most is 2. Is how many appearance? 5 times. Or 5 appearance. 3 is on appearing once, and then 4 is on appearing twice. That one means that our mod is 2. As simple as that. Just you need to know the values of x which are appearing most. The variables which are appearing most is our mod. The variables which are not appearing most is not the mod. So how do we get the third one is called? Now for mod is just that simple thing. The third one is what we are calling median. The third one is what we are calling median. Median is the middle value of the distribution obtained after the values have been arranged in either ascending or descending order. Median is the middle of the distribution obtained after arranging the variables in either ascending or descending. In either ascending or descending. So What is our median? Median, we have said, is the middle values of the distribution obtained after arranging the variables in either ascending or descending. So, for example, if x is given by 1, 2, 2, 4, 5, 1, 2, 7, 1, 2. And the 6. And they say find the median. Find the median value. Find the median value. We said that is the middle value of the distribution obtained after arranging the variables in either ascending or descending. So find the median value. The median value is given by arranging this one in either ascending or descending. We shall arrange them 2 times. So the first one, let us arrange it in ascending. Arranging in ascending. So we have 1, 2, 1, again 1, again 1. Then we have 2 how many times? 1, 2, 3, 4 times. 1, 2, 2, 2, 2. And then after 2 we have 3 and 5, and we have 4 and 5. 4 and 5, and then 6, 7. So we say the middle value that appear most, or the value which is in the middle, is what we are calling median. If you cross this one and 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 this one, the middle one is our median. Now using the ascending method or using the ascending arrangement, our median is 2. Then that's our median is 2. Then let us try arranging in descending. Arranging in descending. Arranging in descending. We have, if we are arranging descending, we have descending means from the highest to the lowest. Now in these variables, or the number given, the highest is 7, then 6, then we have 5, then we have 4, from 4 we have 2, which are 4 times, 2, 2, 2, 2, and then 1 which appears 3 times, 1, 1, 1. So we say the middle value is the median. We can cancel this and this one, that one, the first one. This one go with this one and this one, until we get the value which is in the middle. Which one is in the middle? Is 3, 2. So our median is 2. So this one means that even though you use ascending and descending, even though you arrange your values in ascending and descending, in both cases median will remain the same. In both cases median will remain the same. And in cases where you get different medians, for the same values but arranged different. Then you have made some mistake in your arrangement. So that's how we calculate in median, given that you have variables. Now what if you have cumulative frequency? So median is given by, median is also given by, is also given by, n out of 2 of n's number of n out of 2 of the cumulative frequency. Median is given by n out of 2 value of the median is given by n. If your n is 10, you divide by 10 by 2, which is 5. And then you come to cumulative frequency, and then you get where 5 is fitting, and then you get the variables from x and its value. So that's how we shall be calculating median, mode, and the mean of the median, mode, mean, and the median, mode, and mean of the ungrouped data. That's the area measurements of central tendency. So, some important definitions which we need to look at. Frequency, which is denoted as small f. What is the frequency? Frequency is the number of times the value or the number of times an item appears. Frequency f is the number of times an item appears. That's the frequency. The number of times an item appears is what we are calling frequency. You have been looking there, frequency, but without knowing its definition. So frequency F is the number of times a value appears. Frequency is the number of times a value appears or an item appears. If you have a value occurring more than once, then there you need to use frequency table to make it easy. So to obtain frequency, okay, if that frequency, if a value appears more than one time, it is better to use frequency distribution table. It's better to use frequency distribution table if a value appears more than once or more than twice. That is obtained. Then frequency, if you have done your frequency distribution table, it is easily obtained by tallying the data. Then frequency is easily obtained by tallying the data. When you are tallying the data, it keeps on representing the number of times that data is appearing. Then after getting the overall, or after finishing the data which you are tallying, then you get what we are calling the frequency, which is now the number of times that tally you have put. If you have put 2 strokes, or if a data is appearing, you cancel it and then you represent it with a bar, and then with another bar. After finishing, that's what we are calling the tally. And then after finishing, to get frequency, you count this one, which is 1, 2. Implying here the frequency is 2. Remember that frequency we denote it with small f. Frequency we denote it with small f, and then frequency we denote it with small f, and then we have what we are calling cumulative frequency. The second note we have in what we call cumulative frequency. Second one we have cumulative frequency. We call it as our CF. It's better call it as CF in order for you to note the values. So cumulative frequency is just defined by the running total of frequency, or the summing of the frequency, defined by the running total of frequency. The running total of frequency. That if you have example, if you have our F, and then this one is column for cumulative frequency, then we have X as the first value as 1, this one 4, this one 2, 1, 4, and then this one is 3. So the first cumulative frequency is always the first frequency, which is 1. The first cumulative frequency is always the first frequency, which is given as 1. Then the second cumulative frequency, the second is got by 1 plus the second frequency. So our second frequency will be 1 plus 4 equals 5. So this one becomes our second cumulative frequency. To get the third cumulative frequency, we get 5 plus 2, which is 7. And then the third one, we get 7 plus 3, which is 10. So you have that if you get the summation of f is 1 plus 4, which is 5 plus 2, 7 plus 3, which is 10. Another key thing to note here that always it is a must. The first cumulative frequency is the frequency, the first frequency. And then the last cumulative frequency is always the total number or the sum of the frequency. Summation of f must be equals to the last cumulative frequency. If you don't get that one, then you have done it in your own ways, implying there is something wrong there. You need to be conscious here when you are dealing with cumulative frequency. If you don't use one, the first cumulative frequency as frequency, then there you are wrong. And then to get the second one, you say you add 1 plus 4 to get the second one, which is 5. And then to get the third one, we have 5 plus 2, you get the third one. So you get the current frequency. To get the current frequency, you get the cumulative frequency before, plus that frequency which is after. That's how you get that one. So this is how we shall be looking at this thing. So basically that's the new introduction to statistics. So let us look at the examples. So let us look at the examples. Example, given the following sets of values. Examples. Examples. We have given the following sets of values. 1. The following sets of values. Values which we have 2, 1, 3. So for that, 2, 1, 3, 4, 5, 6, 7. 2, 1, 3, 4, 5, 6, 7, 8, 9, 10. 9, 10. 2, 1, 3, 4, 5, 6, 7, 8, 9, 10. 3, 4, 6, 8. 3, 4, 6, 8. 3, 4, 6, 8, 9, 6, 8, 9, 6, 3, 2. Given those values, which is 2, 1, 3, 4, 5, 6, 7, 8, 9, 10, 3, 4, 6, 2, 9, 3, 4, 6, 8, 9, 6, 3, 2. The question is saying find the one. Find the first one is A, yeah. Find the mean. B, yeah. Find the mod. Then C, yeah. Find the median. Those are the three examples. I mean, that's the first examples and what we need to tackle. So, in those table, we need to form what we are calling the frequency distribution table. Why? We say that if you have an item appearing more than one time, or more than one times, you should use cumulative frequency. We have 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 3 is repeating itself, 4 is repeating itself, 6 is repeating itself, and then 8, 9 are repeating themselves, and then 3 is repeating itself for the third time. So what do we need to do? We need to form a frequency table for ungrouped data. Need to form the first thing, our first solution form frequency distribution table for ungrouped data. Form frequency distribution table for ungrouped data. So, what we need to do to form the frequency distribution table for ungrouped data. So we start. We say our first column will always be the variables x. Our first table is variable x. So where is our variable running from? We start rearranging this one in ascending orders. So let us start. If our variable is 1, that is the least value, and then the greatest value is 10. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then repeating themselves. So our first variable is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it is not fitting here, so we are going to adjust. To adjust our table up here. We are going to adjust our cumulative table up to here, which is x said our x, the first one is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So make sure I use make sure I use a ruler to draw this line. They must be straight lines, and then the table must be organized to cross the table from both sides. So after, then we have what we are calling the frequency F. Then the frequency F, since they want our mean, then we shall get what we said we are calling Fx. And then since they want median we said it is for cumulative frequency, so we shall include what we are calling cumulative frequency. That's why our table stops. So we say that we are going to use the tallies. So how do we get the frequency? We say we get frequency from the tallies. So we shall get the first table, which is tally, then the second table, which is frequency, and then this one cumulative frequency, and then we have our table f of x. So, how do we cut tally? We are going to use two different pens here now. So, I'm going to be cancelling here and put it where it belongs, such that I don't repeat myself. You may count 1 is here, 2 is here, and then you end up repeating yourself. How are we going to do? You cancel 1 at a time. Because now we are going to, the first value is 2. We cross it as 2, and then where is it going? It is coming here. So we are going to represent it with 1 bar. That one is meaning that it is now appearing 1 time. Then the second one is 1, which will be here, the third one. Then we do it for all the values which we have, up to the last value, which is 10. And then this one is 3, then you come back where is 3? 3 is here. Right now we have 2 values of 3, then 4, then 6, then 8, then 9, 6, this one is for 9, and then this one is for 6 again, then this one is for 3 again, then this one is for 2. There we have finished what we are calling tally now. We say the frequency is got by counting the number of sticks which we have. Now here we have 1, implying the value is appearing 1 times, 1, 2, implying it is appearing 2 times, 3 it is 3 times, this one is 4, which is appearing 2 times, then this one is 1, which is appearing 1 time, this one is 3, which is 3 times, this one is 1, this one is 2, this one is 2, and this one is 1. Immediately after finishing getting the frequency, what we do next is summing the frequency. You must sum the frequency immediately. So when you are summing the frequency, what we have? We are going to add from the first step to the last. So we have 2 plus 1 gets 3, plus 3 6, plus 2 8, 9, 12, 13, 15, 17, 18. So we have 2 plus 1, 3, 6, we get 8, we get 9. We get 9, we get 12, we get 13, we get 15, we get 17, we get 18. Now the values are 18. Summation of frequency is 18. So what we start, we say that our first cumulative frequency is always 1. The second one you get 1 plus 2, you get 3. 3 plus 3 you get 6. 6 plus 2 we get 8. 8 plus 1 we get 9. 9 plus 3 we get 12. 12 plus 1 we get 13. 13 plus 2 we get 15. 15 plus 2 we get 17. 17 plus 1 we get 18. So since this one is equal to this, then for this column and this one we are correct. So now summation of fx, I mean fx is got by x times f or f times x. Here we multiply. So we have 1 times 1 which is 1, 2 times 2 which is 4. We don't use this column of CF, we use column of F. So 2 times 2 which is 4, 3 times 3 which is 9, 4 times 2 which is 8, 5 times 1 which is 5, 6 times 3 which is 18, 7 times 1 which is 7, 8 times 2, 16, 9 times 2, 18, 10 times 1, 10. Then immediately also here after finishing, you get what we are calling summation of f and x. You get what we are calling summation of f and x. You also get your calculator and then you add. So the first one is 1 plus 4, 5 plus 9, 14 plus this one 22 plus 5, 27 plus 18 we get 45. 27 plus 18 we are getting 45. 45 plus 7 we are getting 52. 52 plus 16 we are getting 68. 68 plus 18 we are getting 86. 86 plus 10 we are getting 96. So we have finished our values. Let us start getting the question which they are asked. Now part A of the solution is saying calculate the mean. But we say the mean, if you are given frequency, mean f is given as summation of fx out of summation of f. That one is the value of mean. So what is summation of fx? Summation of fx is 96 out of summation of f, which is 18. What is the answer? Say we use calculator to be sure. If you don't waste your head, use calculator to get the correct answer. So our mean is giving us 5.333 recurring. So this one become our mean. So the part B is saying mod. The part B is saying mod. So our mod, we said it is a number which appears most. So here we have two numbers appearing most. That is 6 and 3. Now for the first case, we can take mod as so we have two values which are appearing most. If there are two values, how do we calculate the mod for ungrouped data? You add the 2 and then you divide by 2 because it is the one which is appearing most. Since there are two, we have mod is, the first one we have mod is 3 and then 6. So those are the values which are remaining after arranging. We have 3 which is having 3 times and then 6 which is 3 times 6 which is 3 times. So this is our mod. So say this one we add and then we get the difference. So let us say our mod equals to so mod is equal to 3 median C equals to median, we say it is given by n out of 2 NC value. So what is our n out of 2? N is 18. N is 18. Median, you get n out of 2. That value which right there is 18. So you get where that values lie. So median is 18 out of 2. So we get what we are calling the 9C value of cumulative frequency. If you come on cumulative frequency, where is 9 going? And it has no remainder. It is going in this one. So our median become 5. So our median become 5. So that's how we are going to be tackling this topic. So thank you for listening.